What is electrical tape? How is it made, and how does it work? Have you ever stopped to think about how something as simple as electrical tape is essential for the safety and operation of almost everything around us? That black, colorful, or even white roll of tape that we find in electrical installations, automobiles, and electronic devices hides a fascinating story of engineering, decades of innovation, and material science that prevents accidents and keeps electricity flowing safely. But what exactly is electrical tape? In simple terms, electrical tape is an adhesive material specifically designed to prevent the flow of electrical current. It works as a protective barrier between energized conductors and the surrounding environment, preventing electric shocks, short circuits, and failures in electrical systems. Beyond insulation, electrical tape also protects wires against moisture, abrasion, chemicals, and temperature variations. It is not only used by electricians. It can be found inside smartphones, computers, vehicles, industrial machines, aircraft, and even spacecraft. The history of electrical tape. The history of electrical tape dates back to the early 20th century, when the rapid expansion of electricity created the need for practical solutions to safely insulate electrical connections. Before modern electrical tape, technicians used cloth tape coated with materials such as tar, varnish, or other compounds. However, these materials lacked flexibility and often lost their effectiveness when exposed to heat and harsh environments. The major breakthrough came in 1946 when the company 3M, Minnesota Mining and Manufacturing, developed the first PVC electrical tape. The innovation was the combination of polyvinyl chloride, PVC, with a synthetic rubber adhesive, creating a flexible, durable, and highly insulating product. Its reliability quickly made it popular in military, industrial, and civilian applications, becoming one of the most important safety products in electrical engineering. How is electrical tape made? The manufacturing process is a precise combination of chemistry and engineering. It begins with the base material, usually PVC, selected because of its flexibility, durability, and excellent electrical resistance. The PVC is processed into a thin, uniform film. Next, plasticizers are added to improve elasticity and allow the tape to adapt to different temperatures, typically ranging from around -18 degrees Celsius to 80 degrees Celsius. After that, a synthetic rubber adhesive, such as styrene butadiene rubber, SBR, is applied to one side of the film. This adhesive is enhanced with special resins that provide instant bonding, even on irregular surfaces. Finally, the tape receives protective treatments to improve resistance against moisture and ultraviolet radiation before being cut and rolled into the familiar rolls we see every day. A curious fact is that the most common black color often comes from carbon-based pigments, which can also improve resistance to heat and UV exposure. How does electrical tape actually work? The magic behind electrical tape lies in the combination of its dielectric and mechanical properties. PVC has high electrical resistance, creating a barrier that prevents electric current from passing through the material. When wrapped around an exposed wire, it forms a non-conductive protective layer that prevents electrons from escaping and coming into contact with people or other conductors. Electrical tape also seals the connection against dust, moisture, and chemicals while providing mechanical reinforcement by reducing vibrations and movement that could damage the wiring. For maximum effectiveness, professionals usually overlap each wrap by approximately 50% to 70%, creating a continuous protective barrier. However, electrical tape does not last forever. Over time, excessive heat, sunlight, chemicals, and aging can degrade both the adhesive and the PVC, causing the tape to become sticky, brittle, or cracked. Are all electrical tapes the same? Not at all. Different types of electrical tape are designed for different applications. The most common type is PVC or vinyl electrical tape, generally used for low and medium voltage applications up to approximately 600 volts. It is available in various colors that can be used to identify different wires and phases. Rubber electrical tapes are designed to be stretched and fused around connections, creating a second skin around high voltage cable joints and electrical substations. Varnished cambric tape, made from cotton fabric impregnated with special varnishes, can resist temperatures up to around 105 degrees Celsius and is commonly used in electric motors. Mastic tapes contain a butyl-based sealing layer that creates excellent waterproof protection, making them ideal for underground and outdoor installations. PTFE, commonly known as Teflon tape, can withstand temperatures up to 200 degrees Celsius and aggressive chemical environments, making it suitable for aerospace and chemical industries. Fiberglass tapes can handle extreme temperatures of up to approximately 500 degrees Celsius and are used in furnaces, turbines, and welding protection. Why is electrical tape so important? Imagine a world without electrical tape. Exposed electrical connections would significantly increase the risk of fires, electronic failures, and dangerous accidents. Electrical tape is a simple but vital barrier that improves both safety and efficiency. In the automotive industry, it helps organize and protect complex wiring harnesses in very small spaces. In construction, it protects electrical connections in environments exposed to humidity and harsh conditions. But proper insulation alone is not enough. A safe electrical system also depends on correct planning, proper wire sizing, adequate circuit protection, and professional installation. The future of electrical tape. Electrical tape continues to evolve alongside modern technology. Today, flame-retardant electrical tapes are essential in aircraft, data centers, and other critical environments. Heat-shrink versions combine electrical insulation with mechanical protection, creating stronger and more reliable connections. Sustainability has also become an important focus. Companies such as 3M and Hellermann-Titon are developing products using recycled materials and environmentally safer adhesives. Researchers are exploring smart tapes with integrated sensors capable of detecting overheating, as well as advanced materials like graphene nanocomposites that can improve thermal performance. Volts or more are becoming increasingly important.